All right, so we've done lots of expansion for the last week, right? We spent a whole entire week of our lives expanding brackets, right? It must have just seemed like eternity for you guys, right? We expanded one set of brackets, then we had two sets of brackets that were apart that we expanded, and we had to put it all together. Then we had brackets next to brackets, we expanded them. What a huge week it was for you guys. And it would be nice to go back to simpler times when we weren't locked up at home. We didn't know how to expand brackets. Uh, you know, those days are long gone, right? The age of innocence is dead. Uh, we know how to do that now. What we're going to do now for the next half a week is learn how to undo all that work, learn how to do the opposite of everything you've just done. In maths, it's really, really important. Once we learn how to acquire a skill, build a skill, do something, we learn how to pull it all apart again and do the opposite, right? So back in grade prep, you started learning how to put numbers together with plusing, and then you had to learn how to take them away from each other. Multiplication came first and then division came next to undo that. And now that we've expanded brackets, the next thing that we learn is factorization, right? So expanding was going one way. You had a bracket, you had some stuff on it, and you expanded those brackets away, right? We did some multiplying in, and then there weren't any brackets anymore, right? The brackets were gone, right? Because the 5 came inside those brackets, pulled them apart, and multiplied everything by 5. Uh, we're now going to go backwards. We're going to start with something that doesn't have brackets, like a couple of terms like this, and we're going to put it back inside its brackets and undo all the hard work that you just spent the last week building up. So factorization is called that because it is derived. It comes from the idea of factors, right? We're working with factors, and you've been taught over the years that factors are just smaller numbers that go into bigger numbers, or numbers that go in evenly when we multiply or divide, that don't have anything left over. So if you can automatically know your factors and you know what goes into a couple of things evenly, what kind of factors different pairs of numbers have in common, you'll be okay, right? So when we talk about factors, we're just looking for any number that'll go in nicely, right? So the only factor of the number 1 would be 1, right? We won't be dividing anything by 1 because we are going to be dividing by whatever number we find, and dividing by 1 doesn't do anything, right? Anything divided by 1 just stays the same. So we wouldn't actually get anywhere if we just spend all our time dividing by 1. But it is good to know that 1 is a factor of everything, right? So 1 goes into 3 evenly, 1 goes into 9, and 1 goes into 15, right? If I'm thinking about any other factor that goes into these numbers, the only other number that goes into 3 is 3, right? Thinking about numbers that go into 9, we know that the number 9 will go into 9, right? Because any number goes into itself, right? So 15 goes into 15. And then there is another number that goes into 9 evenly, right? It's 3, because 3 times 3 gives me 9. And then we have another pair of factors for 15, right? If I'm thinking about numbers that are factors of 15 that go into it, think about your times tables and think about what pairs make a 15, right? So 3 goes into 15, and 3 times 5 is 15, so 5 is a factor as well, right? So if you can quickly look at numbers and identify the factors in it, you might have a better time today. All right, so the big question will obviously be, how do we do this factorization business? You're going to be given a couple of terms today, two separate terms. And there'll be things that you cannot add together and cannot subtract from each other. Okay, what a lot of people start to do when they get into factorization is they ignore the fact that they've been taught how to factorize, and they just try and put these together and say it's something like, minus 9 or something like that, because 3 take away 12 is 9. We can't put these things together because they're different. You've been asked to factorize, and that means putting things in brackets, right? If somebody says factorize this, you're going to open up some brackets and put some stuff inside, right? So there's always going to be something on the outside, right? This one has a 3 out the front, this one has a 10 out the front, this one has a 3 out the front. And the key to finding these numbers, right? If you can find these numbers and find the right number to put out the front, then you're well on your way, right? And these numbers, like 3, 10, and 3, are going to come from looking closely at what you've been given to start with, right? I've been given a 3 and a 12, and this is the number I'm choosing to put out the front. Same thing here, right? I look at 20 and I look at 10, and for some reason or another, 10 is what I put out the front. And from 9 and 6, it turns out 3 is my best number to put out the front. As long as you can choose that number to put out the front, well, hopefully you'll know your basic divided by number facts, but otherwise your calculator will do divided bys for you. All right, so just so you know what factorizing is, and you don't have to refer back to a video or anything like that or rely on your memory to do it. This is what you put in your glossary, right? We've got a nice screen for you here with the description. We have an example to do as well. So very clear, right? To factorize an expression, we're going to be looking at both parts of our work, right? We've got the 10x, we've got the 100, and we just want to find a number or a factor that both of these have in common, right? We want the biggest possible number that goes into 10 and 100 evenly, right? Not a big number that they go into. We're not timesing them together or anything. We want a number that's going to be smaller than 100, right? Might be smaller than 10. It has to be a smallish number that goes into 10 and goes into 100. So just for this example, I'm going to list all the numbers that go into 10 and 100. All right, 1 goes into everything. Both of these numbers are even, so 2 would go into them. The number 5 goes into all of these evenly. And because they end in a 0, though, the number 10 goes into them both, right? So the most important number in our work here is, for this question, the number 10, right? We wanted to find the biggest number that goes evenly into both of these parts, right? So then we can set out our answer. So that number that we've just found, the 10, right? It's the first thing we put in our answer. And then we're going to open up a nice set of brackets, and we need to divide each term by that factor, one at a time. So we start by going 10x divided by 10. Okay, so 10x dividing the 10 away will just leave me with x. Then I've got 100, right? It's a plus there, it's a plus there, so it's a plus there. A 100 divided by 10, and that gives me 10 as well. All right, so factorizing means I find a factor and I divide it away, right? And then we're done with this. And then once you've got your answer, the best thing to do to check that you've actually factorized correctly, because we've all spent a week learning expanding and we're really excellent expanders now, we're experts at expanding, just have a look at this thing that you've made out of your factorization, and to check whether this does really factorize down here into that, just think about what it would look like if it was re-expanded back out. So if you chuck that 10 onto that x and you chuck that 10 onto that 10, does it make 10x plus 100? And we know 10 times x is 10x, and 10 times 10 is 100. So that means we factorized it properly. We found that 10, that common factor, and we got it the heck out of there. We divided it down into its factors. So to finish this one off, let's just go through a whole bunch of examples and just get used to this process. So even though all of these things have pluses and minuses in between them or in front of them, we're not plussing or minusing anything together. We're taking a good look at the two parts of the algebra we've been given. We're looking for something they have in common, some small number that goes evenly into them both, and then we're going to set up a division and divide it all down. Right, so everything's going to have brackets. Feel free to just write your brackets first, understanding that something's going to go inside them. We need something to put out the front, so we look at 3x and we look at minus 15, and the only number that would go evenly into 3 and 15 is 3 itself, right? 3 goes into 3 and 3 goes into 15, so we put a 3 out the front because that's that evenly dividing factor. Now that I've decided that 3 is my number of choice, I divide each part by 3, so we start by dividing that by 3. That would make x. There's a minus in my question, so I put a minus in my answer, and 15 divided by 3 is 5. All right, we're looking for the biggest and best numbers that we can to divide out, right? So I got my bracket set up. I want a number to put there. You might look at it and think they're both even, so I'll just divide by 2. But if there's a bigger number, you have to divide by the biggest number you can, right? So 3 goes in evenly, but 6 is the biggest and best number that goes evenly into 12 and 18. So we're going to put 6 out the front, and we're going to divide each thing by 6. So 12y's divided by 6, we just divide the numbers by each other. So 12 divided by 6 is 2, and we leave the y there. There's a plus there, so we'll put it here. And 18 divided by 6 is 3. All right, next one, we got 12y, we got minus 24, the biggest and best number that goes into that. All right, I'll set my brackets out, but I need to put a number at the front, and that number is 12. Right, often just this number at the front might go into them both, and then that's going to be your number of choice. 12y divided by 12 is y, and minus 24 divided by 12 is minus 2. All right, now these ones on this side are a little bit different, because one thing you might notice is both parts have a minus out the front. So what we encourage you to do when both parts of the thing you're factorizing have a negative, we try and factorize out whatever's common to both parts, and if they're both negative, you should put the minus outside as well. Right, I didn't do it with this one here, and I didn't do it with that one there because they're not both negative. It's only when they're both negative that we're going to divide that negative out. Okay, so we put a negative out the front because both of our things are negative, and 4 is the best number that goes into 4 and 8, right? Negative or positive, doesn't really matter. Just look for the biggest number that goes into both of these values. All right, so when I divide this down, what's going to happen now, because I divided the negative out of both of these, there's no more minuses, so I don't need to put minus in front of this, I just put x, right? The minus and the 4 got factorized out of this minus 4x, and x is the only thing left. We put a plus, because it was negative, but I got rid of the negative, and 8 divided by 4 is 2. Okay, so same thing here. We're looking for the best number, but it has to be a negative number, because both of these are negatives, and the best number that goes into 7 and 14 is 7. So now that I've decided that, I just have to divide 14 by 7, put a p there because it's part of it, put a plus, and put a 1. And with the last one, again, it has to be a negative factor that comes out, and 3 is the number that goes into 3 and 18. So when we divide it down, that'll be u, and it'll be plus, and it'll be 6. All right, so just make sure that if both are negative, you divide that negative out, and then that will leave nothing but positive values inside, right? The negative got divided away, so everything's positive now. But only do it if they're both negative, right? I didn't do it here, but I did it there. All right, good luck with today's work.